Okay, so the last couple terms we'll talk about: compiling versus interpreting a program. People say, oh, this is a compiled language, that's an interpreted language. What do those mean? Compiler usually means that a compiler is a function that takes in a source code or takes in a program in one language, say C, and it returns a file or produces a file of machine code. And the idea is hopefully is equivalent. Whatever the semantics of that C program were, they match the semantics of this assembly language program that's produced here. So think of translating a program from one language to another. Okay. And an interpreter, on the other hand, says, hey, I'm going to go ahead and I'm going to read a file, PHP and Racket, JavaScript interpreted languages. Hey, I'm going to go ahead and I'm going to read a file and all the commands in the file, and I'm going to build up a data structure, and I'm going to sort of figure out what these JavaScript commands are supposed to be doing and how they would update the memory. And then I'll look at the next line of code and update the internal state, and next line of code, update the internal state, the memory locations, and so on. And so that's an interpreter. So if you look at what machines are actually running on the silicon, what actual machine code instructions are getting run, in an interpreter, the opcodes that are actually running on the machine are the opcodes of the interpreter thing that was written like years ago. Okay, the PHP interpreter was written 2 years ago that you're using. You're running your PHP program you wrote 5 minutes ago, but the opcodes on the machine are these old instructions that are just reading in your file and updating things based on that. As opposed to a compiler, if you take your C program and compile it to assembly code, and then you make a second pass and you actually run your machine code, well, the instructions running on the silicon are the machine instructions just generated a few moments ago from the program that you wrote in C. So, okay. I should point out that a lot of people say, oh, this language is a compiled language, that language is an interpreted language. It's a little bit of a misnomer in that, I can compile C code and I can interpret C code. I can take JavaScript and I can compile it or I can interpret it. Okay, I can compile it down to machine code or I can interpret it. So it's not one or the other. It's just that in practice, the dominant way of running that code is running that program in that language is to either compile it for one language and another language you tend to almost always interpret it. So you tend to not. So technically, it's not that a language is compiled or interpreted. It's just that I have a compiler for this language or I have an interpreter for this language, and you tend to have one or the other. Okay. And, compiling is actually a little bit more general than I just stated. Compiling just really says take a program in one language and produce a program in another language. Often that other language is machine code for a particular platform. But it could be I can have a cross-language compiler. I can say, hey, I'm going to take in JavaScript code and I'm going to compile it and produce C code, equivalent C code. Okay? Yeah, you could do that. People actually often go the other round. They'll take some other weird language, not weird, but some other language that define themselves, and they'll compile it into equivalent JavaScript. Why JavaScript tends to be a popular target of compilers? JavaScript runs almost everywhere because it runs in every browser, and everybody has a browser in their pocket, on their watch, everywhere these days. So you can compile to machine code, but you can also equally well compile to another language. Okay, interesting that JavaScript is itself an interpreted language, usually. So your browser is interpreting the JavaScript. Okay, anyway. Yeah, so let's go and, again, another way to look at the distinction between what interpreted code does. The interpreter is looking at the source file, the program source, the high-level source, as if it were data. And as you interpret it, you're maybe updating internal memory configurations. Whereas compiled code, you go ahead and actually, once you've compiled it, you run the actual code. You don't go and look at your original source as if it were data. Okay. Compiled code can be faster, has the opportunity for being faster. It's not necessarily inherently faster, but because you're generating machine code, and the opcodes that are actually running are all about solving your original problem, and they're not about looking at somebody else's file as a source program. It has the potential to be faster and run faster in practice. So, on the other hand, once you compile down to a certain assembly language, you are tied to that language. This is assembly code that now runs on an Android cell phone, and you need to recompile it and have a different binary that goes ahead and runs that equivalent program on, say, a Windows desktop Pentium processor or whatever. Okay, so, interpreted code, I guess there's still that problem. You need an interpreter on every place where you actually want to run it. But that is done. In fact, one big example now is the JVM. Java is a hybrid model. Java is both compiled and interpreted. You compile Java down to bytecode, some intermediate format that they made up. Okay, the Java people made it up. And it's a format that's pretty easy for an interpreter to handle on almost all all common assembly platforms, assembly languages, because the commands that are there that it's trying to interpret are pretty close to machine opcodes that it can do. So, yeah, you compile the bytecode, and then you have an interpreter. The interpreter, name of the interpreter, 3 letters, starts with J. Yeah, the JVM is the interpreter, the Java Virtual Machine. And so you need a Java virtual machine for every different platform that you want to run Java on. But the nice part is you only need to compile once to get a class file. You can distribute that class file, the same class file, to all your customers. They don't care. It doesn't matter what platform they're running. They run the same .class file as long as they have a JVM. They got that from a specific to their hardware. So, okay. If you think about the distinction between compiling and interpreted too much, if you get a little bit too academic about it, the distinctions really start to blur. What is compiling? What is interpreting? In particular, I've thought about it too much, and so I would actually claim that assembly code is interpreted. Who's interpreting it? The hardware, the actual silicon. The hardware designers make something that goes and it looks as your assembly code as data. It just looks in memory and said, oh yeah, here's an opcode, the move opcode, and here's the division opcode, and I'm going to go, based on what I just read in memory, I'm going to go update my internal registers right here in the CPU based on what I read in memory. Wait, that sounds exactly like interpreting, reading the code as if it were data and manipulating your own internal memory based on that. So people, I think, tend to overemphasize the difference between compiling versus interpreting. I would just like you to especially be aware of thinking of a compiler as a program that takes in a program in one language and produces a hopefully equivalent program in another language, while an interpreter takes in an expression, a program in a language, and figures out what its result is, the result of running that program. So, okay, thank you.